works the same way as shifting a quadratic. That's what's so nice is once you know how to shift one function, you can shift the rest of the functions all year. If you end up taking a college class, this is a huge focus as well. So it'll be good. Okay, so everyone, let's look at x squared. This is what's called a parent function. The parent function has no shifts. Not all functions are a shift from a parent function, only special ones, and we'll talk about that in a minute. But right here is a shifted quadratic. Everyone remember this? Yes, everyone? Yes? Yeah. So remember, let's write this down. A negative in front is its own transformation. They call them transformations. This is considered a reflect. This is all memorization. A reflect over the x-axis. So look, think about it. Look, let me show you. If I have this red point right here and I say reflected over the x-axis, if I reflect it over the x-axis, doesn't red go to purple? Well, that doesn't change the x. Look, x is in the same position. It actually changes your y values. So let's make a mental note of that. When you reflect verbally over the x-axis, you're actually timesing your y values by -1. That will fix that'll fix all your points to be the correct reflection. So when you reflect over the x-axis, you times your y values by -1. Then remember, an a value in front is considered a vertical stretch or compression. And what you do is you just times your y values by a. It only affects your y values. So you just times your y values by a. So if a is larger than 1, like 2, 4, 6, 8, it'll stretch it out vertically. The acceleration is faster. If it's a half, a third, do you guys see what I'm saying? 0.7. Yes, everyone? The acceleration is less quick. So they call it a compression. It only affects your y values. Stretch and compressions only affect your y values. So notice what's cool is that -a, both of those affect our y values, and they're both multiplication. So you can hit two birds with one stone. So look right here. This would be considered, like let's do this example. This is a reflect over the x-axis and a vertical stretch by 2. We can kind of get lazy because we're not doing horizontal stretches at our level. You will next year. But at our level, we're just doing vertical stretches, so we can say stretch of 2. So then you can literally just hit two birds with one stone and take your y value and times by -2. See, then you take care of the reflection and the stretch at the same time. Does that make sense? So it's kind of nice, yes? Okay. Then remember, shifts left and right are grouped in parentheses with x. And we verbalize opposite of the sign. So this will be our shift left and right. And we do opposite, write yourself a note, opposite. We verbalize opposite of the sign. So isn't this right 3, everyone? Now think about it. If I take a point and I shift it left and right, that would only affect our x values. So we would take our x values and add or subtract our h. So in this case, so we say right 3, we would take our x's and add 3. Over here. You guys see? Right 3? It's very literal. Go right 3, you would need to take your x's and add 3 to them. Everyone with me? Yeah. And then this is our shift added on the outside. If it's not grouped in parentheses with x, added on the outside is the shift up and down. And we do not verbalize opposite. We verbalize the sign the same as it is. So it stays the same. So isn't this up 4? If you take a point and you need to move it up 4 units, that would affect your y values. So you take your y values and add 4. So what I want to point out is if there's a shift for the y's twice, like right here and right here, multiplication has to come before addition and subtraction. So you would multiply your y values by -2, and then you'd add 4. In this case, there was only one transformation for x. It was right 3. So that would be pretty easy. Now remember what the squared thing is what creates the function. The squared isn't part of the transformation. That's what created the shape. This is a shifted U shape. Do you guys see what I'm saying? You got to be able to nail that down in your head. Okay, so let's graph it. So this is how you do it. This is how you graph transformations. Are there other ways to graph? Yes, and you won't get points unless you do it this way. So you're going to go like this. You're going to write down x squared's parent function. I hope you're all paying attention because even when I teach this to Sec 3 honor students, it's always like, for whatever reason, they're always like, I don't get it. And you guys are a whole year sooner. So here we go. In x squared, do you guys agree that we can plug in anything we want? Or is there going to be i's? There's not going to be i's. What's -1 squared? 1. What's -2 squared? 2. Are there i's? No. So you can plug in anything. So let's plug in things around the origin. Origin 0, 0. So -2, -1, 0, 1, and 2. We don't always plug in -2, -1, 0, 1, and 2, but we do if the domain is -infinity to infinity. If there are no domain issues, you're going to plug in these values probably. Okay, so now you're going to calculate the parent function. Negative 2 squared is 4. Negative 1 squared is 1. 0 squared is
0.
1 squared is 1. 2 squared is 4. Now, I'm not going to make you graph that. That's extra work. Could we? Yes. Is it extra work? Yes. So we're not going to. Let's just now apply the transformations. So we're graphing this. Didn't we say we need to times our y values by negative 2, everyone? So this is us showing our work. We're timesing our y values by negative 2. That will reflect and stretch it correctly. Is everyone with me? Isn't it also up 4? So once we times by negative 2, we then need to add 4 to our y values. I'm just taking care of the y's first, just because there was more shifts on the y's. And didn't we say write 3, everyone? Write 3? Yeah. So you're going to add 3. This is me showing my work. Add 3, add 3, add 3, add 3. And then we're going to go over here and write down the new x and y values. So let's focus on the x's. I'll circle them in red. Isn't this now 1? This is 2, 3, 4, and 5. Does everyone see where I got those? Yeah. Then you would just literally calculate this very carefully. Isn't that negative 8 plus 4?
Negative 4.
Negative 4. Negative 2 plus 4? 2. 0 plus 4 is 4. Negative 2 plus 4 is 2. Negative 8 plus 4 is negative 4. Now when I go graph these, I should say I better have a U shape or I've messed up because I know that a quadratic is a U shape. So we're going to go over 1, down 1, 2, 3, 4. Over 2, up. Wait, did I do that right? Nope, I didn't. Over 1, down 1, 2, 3, 4. Over 2, up 2. Over 3, up 4. Over 4, up 2. And over 5, down 4. And when I connect it, you should be able to make sense of your answers. A normal parabola is at 0, 0 like this, isn't it? Does it look like it was shifted right 3, reflected upside down, and shifted up 4, and then kind of stretched out? Okay, good. So to get the full points on the test, if you're asked to do it by transformations, you have to show your work this way, or else you don't get points. Questions on that? That process is pretty easy, would you agree? You'd have to have foundations, though, to be able to do that. Now, we're going to shift all functions. So everybody look, it's very important that we know what like an absolute value graph looks like. So pay attention. This is where I think in Sec 3 honors, kids get confused. They get confused by the parent function because they haven't memorized some things. So absolute values are straight lines, and they create V shapes. Now, with absolute values, you can plug in negatives and positives, and it doesn't create I's. So let's just plug in negative 2, negative 1, 0, 1, and 2. So when I plug in the absolute value of negative 2, you're just getting positive 2. The absolute value of negative 1 calculates to be positive 1. The absolute value of 0 calculates to be 0. The absolute value of positive 1 calculates to be positive 1. The absolute value of 2 calculates to be 2. So do you guys see how with absolute values, when you plug in a number, it just creates a positive number? Does that make sense? And then that's where I got these points. See, I've graphed them already. There's 0, 0. There's negative 1 up 1 over 1 up 1. You guys see, I've already graphed them. Okay. So in a minute, when there's a shift, you have to be able to go, oh, this is a V shift. Okay, exponentials. Let's look at an exponential. An exponential has a base to an x power. Your focus last year in Sec 1 was a lot of exponentials. We just briefly did some stuff with this year. So this is a parent function. Base 2 isn't what creates any shifts or anything. That's what creates the original graph. What if it was 3 to the x? Doesn't it just grow quicker, everyone? Accelerates quicker upwards. You guys see what I'm saying? But it looks like this. So what I want to point out is exponential functions have horizontal asymptotes at 0. This horizontal asymptote is a value that our graph gets really close to as we go out here to the left, and it doesn't cross it. And if you think about why, here's a key thing to remember. You actually can plug in anything into exponential functions. So let's plug in negative 2, negative 1, 0, 1, and 2. So watch, 2 to the negative 2. It is wildly important that you guys understand negative exponents are not negative numbers. Negative exponents are decimals. I say that again. Negative exponents do not calculate to be negative numbers. They calculate to be decimals. And that's because remember how we can fix this to be a positive exponent is flip it over a fraction. You guys see how I flipped it over a fraction and wrote it as a positive exponent? It's giving me 1/4. See, I told you, that's a decimal, not a negative number. So let me ask again, are negative exponents decimals or negative numbers? Decimals. So it makes sense. What if I go plug in a really big number out here? What if I plug in 2 to the negative 100? That's not a negative number. Isn't that just 1 over 2 to the 100th power? Which is 0.000000002. So you can see that it's just the further out here you get, the closer we get to 0. That's what an asymptote is. It's a value you approach and get really close to. Okay, let's plug in -1. 2 to the -1 is 1 over 2 to the first, which is 1/2. 2 to the 0 is not 0. Any base to the 0 power calculates to be 1. 2 to the first is 2. 2 to the second is 4. So then I've graphed this exponential function, so we could then shift this around. So picture me shifting this left and right. Would the asymptote change if I shifted it left and right? But what if I shift it up and down? The asymptote would move with it. The whole graph shifts. Do you guys see what I'm saying? Okay. All right, moving on to non-exponential. A square root. I need you guys all locking in hard on this because you cannot plug in anything you want here. If you plug in a negative number, you're going to get I. Isn't that accurate with square roots? We don't want to graph I's. We only graph real numbers. And you can't just start randomly. You need to start at the appropriate place, which would be 0. When I ask people what's the first perfect square root, they'll usually say 1, but it's actually 0. What's the square root of 0? What's the square root of 1? Do I want to plug in 2 and do decimals? Heck no. So I'm skipping 2. How about 3? Isn't that a decimal? Square root of 3? How about square root of 4 though? Well, let's pick perfect square roots then. This will be way easier. Then I don't deal with decimals the whole time. Square root of 5, square root of 6, square root of 7, square root of 8, square root of 9. Isn't square root of 9 3? Yeah. And so then I have some points there. I'm picking wise points so I can deal with whole numbers as I go. See, there's 0, 0, over 1 up 1, over 4 up 2. So you guys can see, if you're dealing with square roots, remember that you're going to start at 0 and plug in 1, then 4, then 9. Okay, and cube roots are not the same. So listen carefully. Cube roots don't have I's. You plug in negatives and you plug in positives. Cube roots do not have I's. They have negative numbers. So what's a perfect cube root? Something that doesn't cube root to be a decimal. So think about it. Isn't the cube root of -8 -2? Think about why. -2 times -2 times -2 is -8. So that means the cube root of -8 is -2. It's not I. So the next perfect cube root is not 7. It's not 6. It's not -7 or -6 or -5 or -4 or -3 or -2. It's -1. The next perfect cube root is -1. What's the cube root of -1? -1. What's the cube root of 0? What's the cube root of 1? What's the cube root of 2? It's a decimal. Cube root of 3 is a decimal. 4, 5, 6, 7, 8. Oh, cube root of 8 is 2. Okay, good. So I'm wisely picking these points so I'm not dealing with decimals the whole time. It's just a pain to deal with decimals the whole time. See, there's 0, 0, over -1 down 1, over -8, you can't see it, but it's down 2, clear out here, and then over 1 up 1, and then over 8 up 2. Okay, and then last but not least, they could give you some rando picture and say, this is your f of x. So f of x is just, this is the function. It's just some random shape. There's not really an equation for it. But they're going to give you a graph of a picture. So what you're going to do is just look with your eyeballs. Let's write down some x, y values we see that we could then recreate this picture with shifts. So I just picked some, like enough that I could recreate it. So that would say -5, 0. Then I would say 0, 0. Then I would say over 2 up 4. And then I would say over 6 up 4. Do you guys see what I'm saying? But there's not going to be an equation. They just say f of x. So then they could still tell you to shift it, but they don't have an equation. So they just leave it as like f of x. And then they shift it. They say f of x is shifted. And then they put the shifts on that. Because there's really not an equation for that. Okay, so let's just start practicing. This is how it's going to look on your test. I'm going to give you some random that I just pick shifted function. So this is how your thought process will start next year. You'll say, oh, this is a shift from a parent function. The first thing you do is write down the parent function. Can you tell what the parent function is? It should slap you in the face. Exactly. Absolute value of x. Is everyone agreeing? You just take off all the shifts. So then you'd write down an XY chart for absolute value of x. You'd say to yourself, this is a V graph. I can plug in negatives and positives. So let's plug in -2, -1, 0, 1, and 2. The absolute value of -2 is 2. The absolute value of -1 is 1. The absolute value of 0 is 0. The absolute value of 1 is 1. The absolute value of 2 is 2. Does everyone see how I got those points? Oh, yeah. Now we just perform the shifts. Let's verbalize it in case on the test they say verbalize the transformations. What's the negative? We have to memorize it. Reflect over x-axis. So make yourself a note of that. Okay, a mental note. What is the 1/2? Compress by a half. Let's push pause and write ourselves a note. Aren't we going to be timesing our y values by negative a half then? That's what happens. And a value in front gets times to your y values. So we're going to go just show our work. We're timesing all of these by negative a half. Now this might create decimals as we go, and that's okay. We just didn't want decimals from the beginning. Okay, what is this shift right here? Right 3. So you're going to say, I need to add 3 to my x's. If you're going right 3, you do have to add 3. The only thing that's opposite is in the equation. And then verbalize that transformation in purple? Down 5. So then you would say I'm at a -5. Yeah, he's here. I'll give it to him. Mason, this for you. It says ASAP, so go ahead. All right, let's write down our new points. We know it's a V shape, so if we go to graph our new points and it's not a V, we go, crap, we messed up somewhere. So let's just calculate our new x values. Let's focus on the x's. Won't that be a 1, then a 2, then a 3, then a 4, then a 5? Those ones tend to be the easiest part. 2 times negative a half minus 5. If you couldn't get it right in your head, you would do it in your calculator. 2 times negative a half is negative 1 minus 5 is negative 6. 1 times negative a half is negative a half. Do you guys agree? Minus 5. So wouldn't that be negative 5.5? Or am I nuts? Yeah. 0 minus 5. Why 0? Because 0 times anything is 0. 0 minus 5 is negative 5. 1 times negative a half is negative a half minus 5 is negative 5.5. And then we are getting 2 times negative a half is negative 1 minus 5 is negative 6. Let's go graph it. Over 1, down 1, 2, 3, 4, 5, 6. Over 2, down 1, 2, 3, 4, 5.5-ish. Over 3, down 5. Over 4, down 5.5-ish. And then over 5, down 6. And there's my V. A compression is like this. It's a vertical compression. So that looks about right because a normal V was like this. Oh, I can't. Do you guys see how it looks like compressed this way? Okay, cool. So really easy once you know the transformation thing. Okay, so look at this one. Okay, what would be the parent function here? Anyone know? Parent function doesn't have shifts. What? Yeah, it is exponential. And what's the base? 3. You're right. 3 to the x would be the parent function, everyone. Are you guys seeing it? Look at it. Shifts look the same for all functions, so it makes sense that that's the parent function. So you'd make an XY chart for that. Let's plug in -2, -1, 0, 1, and 2. Exponentials, you can plug in negatives. 3 to the -2, for graphing, it's going to be a decimal. It's 3 raised to the -2. If we're doing fractions, that would have been 1/9, 1 over 3 squared. I'm going to do decimals, so that's 0.1. 3 to the -1, I put it in my calculator and get 0.3. 3 to the 0 is 1. 3 to the first is 3. 3 to the second is 9. We're now going to perform the transformations. Let's stop verbalizing it. I'm not going to write it down. Let's verbalize it together out loud. Stretch to and reflect over the x-axis. That goes to our y values. So we're going to times our y values by -2. I'm going to need a calculator. I don't, in my head, know how to multiply decimals. I really just don't. So it's fine. I'm going to use my calculator. But let's write the rest of the transformations. What is this shift? Shifts left and right are grouped with x. So
x minus 1.
Right 1. You're right. Right 1. So we're adding 1. You got to ask questions if you're having them. Verbally, it's right 1. Everyone good? Shifts left and right are opposite, and they're grouped in with x. You know how I said they're grouped in parentheses? That really wasn't the best way to say it. It's grouped with x. See back here how it was grouped with x? Shift left and right. Okay, so what's this shift? Up 4. Now remember, we used to have a horizontal asymptote for exponentials at 0. That's actually always true for all parent functions of exponentials. Didn't we just say up 4? So we're going to add 4, but also we need to draw in a new horizontal asymptote up at 4. Just so you know. So our horizontal asymptote will be up at 4. We'll draw that in a minute. Let's create our new xy points. So focusing on x's, that'll be -1, 0, 1, 2, 3. The x's are always super easy to calculate. The next one will be a decimal. 0.1 times -2 plus 4, I did it in my calculator, is 3.8. 0.3 times -2 plus 4 in my calculator is 3.4. I just did that in my calculator and that in my calculator. I'm then doing that in my well, I don't need that in my calculator, but that's just me. I think I'm getting 2. Then right here is -6 plus 4, which is -2. And then isn't that -18 plus 4? Yeah. So -14. So let's go draw in our horizontal asymptote up at 4. All exponentials have horizontal asymptotes at 0, and then the shift up and down will be your new horizontal asymptote. So our points, we know, because we are burning it into our minds, exponential functions should grow exponentially and head towards the asymptote. So if that's not what our points look like, we're going to say, oh, something's off here. It should look exponential. So -1 down 1 to 3.8. Over 0 down 1 to 3.4-ish. Over 1. Did I do something wrong, or does that look right? Are we good? Oh, wait. Oh, yeah, I'm glad you guys are with it today. So you're saying -1 up 1 to 3.8 would have been up there. Over 0 up 1 to 3.4. That was hard for me to do correctly because it's so small. Over 1 up 2. Over 2 down 2. Over 3 down 14. Wouldn't that be like down there? Yeah. And then you should be saying to yourself, does my graph appear to look exponential in format and approach my asymptote? Yes. It shoots down exponentially. Do you guys see what I'm saying? Normally, in all exponentials, without any transformations, shoot upwards. So it was reflected upside down over the x-axis, shifted up to the right one. Yeah, it looks good. All right, and we're almost finished with the lesson. We really are, because then a lot of these go quick. Okay, here we go. This is the one that gets people. I don't know why. Once again, you would say, what is the parent function? It is square root of x. What happens is people start trying to do some weird stuff here. Remember, square roots have eyes. They're a unique function. So you can't do -1. So where should we be starting? At square root of 0 is the first perfect square root. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 5, 6, 7, 8, 9 is 3. I don't want to do decimals. Can you? Are you allowed? Yeah. Is it silly? Yes, it is silly. You should burn it into your mind. A square root function, let me show you, is a sideways parabola. Do you guys see how that's a sideways parabola cut in half? Okay, so burn that into your mind so that when you graph your shifted function, you can go, oh, that looks right. So isn't this reflection over the x-axis? So we're going to times our y values by -1, everybody. We're going to go verbally left 3, so we'll -3. What's this verbal shift here? Down 1, so then we're minusing 1. So now we're going to write down our new official xy points. So now we're doing, I'm trying to change colors here. 0 minus 3 is -3. 1 minus 3 is -2. 4 minus 3 is 1. 9 minus 3 is 6. 0 times -1 is 0, minus 1 is -1. That'd be -1 minus 1 is -2. -2 minus 1 is -3. -3 minus 1 is -4. A lot of kids will get the right idea here, but they won't draw the correct graph when they connect their points. So go -1, 2, 3 down 1. -2 down 2. Over 1 down 3. Over 6 down 1, 2, 3, 4. When you connect it, it should look like a sideways parabola cut in half, and it does. Does that make sense to everyone? A lot of kids will accidentally go like this. Watch, they'll like have it keep going, but starts. Like, look, so if you're ever like, wait, I gotta make sure I'm not going past the starting point. If this was the original starting point, 0, 0, this should be your new starting point. So -3, -1. So you can kind of go, okay, that's good. That's my starting point. I didn't go past that. Okay, cool. All right, so let's do a cube root one if you need it. Do you guys feel like you need it? Or you like, we get the picture, write down the parent function points and shift it. What do you guys think? Let's do it. Okay, so you'd write down cube root of x. You'd write down, after this one, it's going to go wildly quick because from here we're not graphing really. Don't be mistaken, there are perfect cube roots and they're not i's. The cube root of -8 is -2. The cube root of -1 is -1. The cube root of 0 is 0. The cube root of 1 is 1. And the cube root of 8 is 2. Are there cube roots in between those points? Absolutely. They're just all decimals. Now a cube root is unlike a square root. Let me show you remind you what a cube root graph looks like in general. This is a really rough sketch. This is what a cube root looks like. It's like a snake, kind of. I don't know how else to describe it. All right, so what are we going to times our y values by? -1/3. True, everybody? A lot of decimals we're going to have there. Left 5, so we'll -5. Because we shift left and right, we do opposite verbally. Up 2, so then we'll add 2, add 2. My stuff looks too sloppy for my comfort here. I'm afraid I'm going to get confused. All right, so now let's make our official XY chart. Let's just focus on x's. Is that -13?
Yes.
-6, -5, -4, and 3? I'm going to have to do a lot of that in my calculator. So I'm going to go -2 times, so -2 times -1/3, and then plus 2 is 2.6. I'm doing that in my calculator. -1 times -1/3 plus 2 is 2.3. 0 times anything is 0 plus 2 is 2. I'm going to have to do it in my calculator. 1 times -1/3 plus 2 is 1.6. 2 times -1/3 plus 2. And now I know there's somebody out there going, haha, the joke's on this teacher because I'm just going to graph it in my graphing calculator. The joke's on you because I have to see this work to give you points. Okay. All right. Let's graph it. -13 down 2.6-ish. -6 down 2.3-ish. -5 down 2, -4 down 1.6-ish, over 3 up 1.3. Does it still look like a snake?
Do you go up first? Is it negative? Yeah, is it negative?
Oh my gosh, I seriously can't graph today, so the joke's, I guess, on me. So you're saying I graphed that totally wrong. Let's try again. -13 up 1, 2.6. -6 up 1, 2.3-ish. That's hard to graph, that difference there. -5 down 2, is that what it is? Oh, no, it's -5 up 2. -4, I don't really know what's wrong with me today. A little something's going on there. Over 3 up 1.3. So does it still look like a snake? I'll ask again.
What?
Yeah. I had graphed my other ones wrong. I had graphed them negative for whatever reason. My brain did that. Okay. Questions on that one? Okay, look at this general function. So look, right here they say f is just in general. So if they said what's the parent function, you just say f of x. Look at it. It's some rando function. So what you're going to do is write down the points you see. You're just going to look with your eyeballs. Oh, so -3 up 4. Then over 0 up 7. Then over 2 up 9. Then over 4 up 7. Is that what it is? And then we're going to just go. Stretch of 2 goes to our y. So we'll times by 2. Then we would say left 3. So we're going to -3 from our x's. Down 4. So we'll -4 from our y's. And then we've got to try to draw it with the same shape. It kind of looks like a hook. I'll have to remember that because it is hard when you have the points written to like draw it the correct way sometimes because there's some curved edges there. So that our new x values are -6, I believe, -3, -1, and then 1. 8 minus 4 is 4. Am I crazy or is that right?
It is correct.
14 minus 4 is 10. 18 minus 4 is 14. 14 minus 4 is 10. So go to -6, up 1, 2, 3, 4. -3 up 10. Okay, -3 up 10. This is hard to draw. -1 up 14. So like up here somewhere. Over 1 up 10. Now, when you draw it, you have to draw it with the same shape. So it had this little like slant, then wasn't it round to connect the next 3? Look at the original. So just try your best to then replicate that. It should look the exact same, just shifted. Okay. Okay, so now from here, this should be extremely easy. Here we go. Because now a lot of it is just write the equation. This just says state the shift from the parent function. So what you're going to say, stretch of 3, everyone, yes? On the test. And you're going to say, we're stating the shift from the parent function. Left 1 and down 4. Does everyone agree? Is anyone confused? Okay. Right here, they would say state the shift from the parent function. So you would say reflect over the x-axis and good, compress by a half and right 3 and last but not least up 4. Okay, good. Do we really need any more like that or you get the picture?
Oh, I get it. So if it's negative, you're always...
Say again? Yeah. So jump down, state the shift from the parent function here. What's this? Stretch 3. What's this? It said state the shift from the parent function. That's all it said. Right 4. And down 5.
Yo, what's the sign for?
That's the parent function.
What do we do with that one?
Nothing. It said state the shift from the parent function.
No, so it doesn't matter.
Correct. Any others? Do you need to see any others?
Negative, you're always going to compress and reflect. You always write compress and reflect.
A negative? No, the negative is a reflection over the x-axis.
Then how do we write compress?
Because there was a 1/3 half. They're their own transformation.
So when it's a fraction,
Yes, it's compressed.
press again.
No.
Negative fraction.
Okay, yes. The negative is just its own thing. You can't try to connect it with the stretch or compression. Yes. And then there's a stretch or compression. It's that simple.
Stretches.
Yes. Correct. Yes. All right, so what would be this shift, everyone? One more. What's this shift? Right 3. You're right. And up 5. So what would have been the parent function on that one? Nope, but I like that you're trying. Can anyone tell me what the parent function is? 1 over x.
Isn't it just x?
No, it'd be 1 over x. What would the 1 be without? You know what I mean? That would be the parent function, 1 over x.
Look like on a graph.
We wouldn't be asked to graph that one at our level. In the college level class you would, but. How about, and next year you will, but they're really easy. How about this one? What's the parent function? Sine of x. What's the parent function of this one?
2x.
2 to the x. What's the parent function here? Absolute value of x. What's the parent function here? F of x. All right, I think we're getting it. All right, so right here, I need you guys to understand not all things are a shift from the parent function. Here's how you're going to know. This is the easiest way to describe it. If there's more than one x, it is not a shift from a parent function. So is there only one x? So yes, right here, isn't there 2 x's? Then you can't call this a shift from a parent function. Is there 1 x? Then we can call it a shift from a parent function. How about this one? Not a shift from a parent function. There's 2 x's. How about this one? There's only 1 x. How about this one? No. So you guys get the picture with that? All right, so now you're just going to work on the homework. You really should be able to finish that in class, I would say, if you actually focus and get her done. And now, like I said, next year you guys will be the smartest kids in the room because you will already know how to do all this stuff by the time you get to this point. You will. You'll remember it. I know you can do it.